Hello and welcome. My name is Chelsea Barraball and I'm from the University of Stellenbosch in South Africa. In this presentation, I will demonstrate GTutor, our interactive feedback system for grammar development. This is joint work with Moeketsi, Raselimo and Professor Bernd Fischer, who are also at Stellenbosch. Our goal is to help students that are taking a compiler engineering or SLE module with grammar development, because this is a core activity in and major learning outcome of such modules, or at least it is in ours. We typically do this as practical work, so the students are given an informal description of the target language, and their task is then to develop a context-free grammar for this language. More specifically, we use antlers so that the students can actually execute and test their grammar. One issue here is that the informal description is indeed informal. It may be imprecise or incomplete or even contradictory. If we look at this informal description of a language, we can find this paragraph, if we scroll down, that reads as follows. A simple block consisting of a semicolon separated list of variable declarations and a semicolon separated list of statements that are enclosed by these keywords constitutes a statement. So for example, can the lists of declarations and statements be empty or can they not be empty? This description is not very clear. So the problem we are addressing with GTutor is how to give feedback to students without pointing them directly towards the faults in the grammar or actually giving them the bug fixes. We focus on an automatic approach because it is easier to scale to large classes, and of course also because it works better with remote teaching. In GTutor, we focus on two kinds of feedback that work at different levels of interaction. First, we provide counterexamples, that is, test cases where the antler parser generated from the student grammar doesn't behave as expected. It rejects a correct test case or it accepts a test case with a syntax error. The problem here is that we need relatively large test suites to test a grammar thoroughly, so we can have too many counterexamples and the students don't find the forest or the trees. In GTutor, we address this problem by classifying all the test cases using the Needleman-Wunsch sequence alignment algorithm over the rule traces, and then letting the students decide whether they want to see further similar counterexamples that are hopefully related to the same error or counterexamples from a new class that are probably related to a different error. Second, we provide rule hints. We show rules that are involved in the counterexamples and so may contain a bug. The problem here is that the number of such rules can also be too large. In GTutor, we address this problem by using our earlier work on spectrum-based fault localization in grammars to reduce the number of rules that are considered to be suspicious. Students can then ask to have the suspicious rules be revealed in the order of their score. So, the guiding principle behind the design of GTutor is that we limit the students' access to the feedback, or more specifically, we require the students to explicitly request feedback information, and then we keep track of the requests and tally up a corresponding penalty, so that asking for more information to get closer to the bug costs more. Let's now have a look at the classification of the counterexamples. We use the Needleman-Wunsch sequence alignment algorithm over the rule traces for this. We use the rule traces and not the token sequences because they represent the structure better. For antler, that means we simply track which parse functions are entered, which also works for negative test cases where a syntax error is expected to occur. We then align these traces by adding gaps so that we maximize the matching positions and minimize the gap and clashes. Let's look at an example. We see here there are two test cases, and these are their corresponding rule traces. We then go over the traces from the left to the right. The first position matches both parsers start with the start rule. Next, we have the priority expression in the upper trace versus the sys block in the lower trace. We could consider a clash here, but if we insert a gap into the lower trace, then we can match the next two rules. After those matches, we get a clash between vardekel at the top and progdekel at the bottom. And then we can add another gap and get a final clash between base type and simple block. We then assign the scores for the matches and the penalties for the gaps and clashes and compute the overall match score. Here that is 13 out of 49. Note that the algorithm actually uses dynamic programming to compute the gaps so that the overall score is maximized. The details of this are in the paper. We then use the alignment scores to classify all of the test cases. We use an iterative clustering algorithm where each test case is scored against all other test cases that are already clustered. If the highest score is above a given threshold, the test case is merged into the cluster corresponding to that score. Otherwise, the test case forms a new cluster by itself. Let's look at an example. Let's assume we have the three clusters shown here already with 2, 1, and 1 test case respectively. And let's assume that the next candidate is this one here. We first score it against the 2 tests in the first cluster, which gives us fairly low scores of 0.07 and 0.1. We then try the second cluster, which gives us a bit better but still quite a low score of 0.38. And we then finally try the last cluster, and here we get 0.79. This is the best score, and since it is above our threshold, we merge the test case into this cluster. For the second type of feedback, we use the spectrum-based fault localization approach that we presented last year in Athens. Check out that paper if you want to know the details. We have implemented these ideas in the GTutor tool. Let's quickly look at its architecture and the workflow before we get to an actual system demo. Both students and lecturers interact with the system, but let's look at the lecturer first. The lecturer's main task is to create the test suite that is used for the feedback. This can be constructed manually, or the lecturer writes a hidden golden grammar and uses a grammar-based test case generation tool to produce the test suite. The student writes a grammar in ANTLR format and submits it to the system, which then runs it through ANTLR to produce an executable parser. It then runs this over the test suite and collects the rule traces. It computes the alignments and uses the scores to classify the test cases in the suite, as we have just described. GTutor also uses the rule traces in the localization component to compute ranked rule spectra. The student can then query the system for feedback of both types and use it to fix and resubmit their grammar. Now, let's go to an actual system demonstration. Since I want to focus on the student view of the system, I have set up the system with the test suite already in place. We will then run through a few grammar uploads, and we will see how the student can use both of the feedback mechanisms we previously mentioned. Okay, let me switch to the demo view. So we will start the demo by looking at the grammar that I will submit to GTutor as a student. So this grammar contains 2 errors. In the production for the input rule, the group encapsulated by the parentheses should be matched 0 or 1s, but at the moment it will always be matched once. And then also, in the production for output, the quantifier, which is this one, matches 1 or more instead of 0 or more. So these are the 2 errors in this grammar that I'm going to use. So now I'm going to go to GTutor itself, and I'm going to log in as a student user that has already been set up in the system. Now I'm going to choose to upload to test grammar, which is the project containing the test suite that will be used to assess the correctness of my grammar. So this is the dashboard that I see when I log in as a student with no submissions. If I want to upload a grammar file, I can click on the New Submission button, and I'm going to upload the grammar file that I just showed. Now you can see that our submission is in progress and is currently being marked by the system. Okay, GTutor is done marking the grammar. These tabs show us how our grammar fared and tells us how many negative and positive tests are failing and passing, and it gives us an overall score as well. So at the moment, the overall score is 53%. The first feedback mechanism that we're going to look at is the counterexamples, which we can find by clicking on the Results tab in the upper right-hand corner. Here we can see the test cases and the results for the submission laid out in a matrix. Each row is a test case, and each column shows whether that test case failed or passed the submission. Clicking on a test case name will show what the test case looks like, and clicking on the red fail block will show the error message and corresponding information. For this test case, it displays this error and also the rule trace of the test case. We can also see the test case clustering quite clearly. In this example, we can see two clusters. The first cluster has 3 test cases, and the second cluster also has 3 test cases. If we want a similar test case to this cluster, for example, we can click on the More button, and it will display another test case belonging to the same cluster. You can see that the rule traces for them are the same, which is why they've been clustered together. If we want a cluster that's a bit different than these test cases, we can click on the New Class button. The reason that it's showing a test case that's passing is that these 2 clusters are the only clusters that contain failing test cases. The second feedback mechanism is the rule hints, which can be viewed by clicking on the Grammars tab in the upper right-hand corner. We can now see the grammar that we uploaded, as well as the rules and their productions. If we click on the Faulty Rules button, we can see our top most suspicious rules in no particular order. If we want to know the order of the suspiciousness of these rules, we can consecutively click the same button, and the system will reveal the order of the rules, starting with the least suspicious and going up to the most suspicious. So these rules have been color-coded as well. GTutor has flagged output as the most suspicious rule, following by input, and then followed by statement, etc. This makes sense since we know that output and input are both faulty rules, as in the original grammar. When we look at some of the counterexamples, we notice that the test cases, for example, these test cases, don't actually have a period, even though they are using the output rule. Since we also know that the output rule was flagged as suspicious, we can conclude that we mistakenly used a quantifier that matched 1 or more instead of 0 or more. Now we can go fix this in the actual grammar and then upload the fixed version again. So we're going to go to our grammar, and we're going to change this quantifier to a 0 or more quantifier. Then we're going to go back to GTutor, back to submissions, and then we're going to upload the fixed grammar again. So it's in progress, the second submission. We're waiting for GTutor to finish marking. So now we can see an improvement in the number of test cases that are passing, as well as the overall score. So the overall score has increased by 44%. If we go look at the counterexamples again, okay, we can see that some of the test cases that used to fail are now passing because of the error that we fixed. So we know we fixed something. Also, if we go to the rule hints, you can see the new uploaded one here, and this is the old one here. Then if we ask to find the faulty rules again, we can see that output is no longer flagged as a faulty rule. So we can conclude that we fixed all the mistakes in that rule. You may also have seen here on the left that this bar fills up when I complete certain actions. This is the penalty meter, and it tries to discourage students from asking for too much help by assigning penalty values to certain actions. Once the meter is filled up, it will subtract a certain penalty value from the total score. In this case, the penalty value is 5. So for example, if I click on Find Finding Rules, you'll see that the penalty meter went up. So if this filled up completely, then 5 would be subtracted from the total score of the students. This is just to discourage a student from basically just overusing the system and asking for too much information. Okay, so this concludes the system demonstration. So, in conclusion, we presented the GTutor system, which provides interactive feedback to students who develop ANTLER grammars. GTutor serves as custodian to a lecturer-provided test suite. It allows students to ask for failing tests that are similar to cases they have already seen or dissimilar, so that they can form or disprove hypotheses about bugs in their grammar. It also provides more direct hints about possible buggy rules, using a spectrum-based fault localization approach. We have successfully trialed GTutor in a small SLE module. Students submitted on average about 6 grammar versions for feedback. They mostly used the counterexamples, even though rule hints were not penalized. In future work, we want to integrate a bottom-up parser generator called CUP. We think the conceptual framework can remain unchanged, so this is mostly an engineering effort. We also want to look into parser visualization techniques to provide more detailed information about why a test fails. GTutor uses some basic gamification techniques, such as a penalty meter. We want to extend this aspect of the system. For example, we can think of a shared leaderboard where all the students can see how everybody else is doing, or we can add a clock to the system to turn it into a race. Finally, we should evaluate the efficiency of the system in a full-scale classroom evaluation. Thank you very much for your time.